Okay, you remember that factoring flowchart where at the very top we factor out the greatest common factor and then we count the number of terms, and then if there's two terms we were looking for difference of squares. Now there will be something else we'll do with two terms. And then if there's four terms, we just finished factoring by grouping. Well, we're going to focus now on the next several videos if there's three terms. Now the only thing is this particular unit, this particular segment is going to be where we're going to factor when the coefficient in front of the x squared term is a 1. Would you look at this problem right here? This is a 1x squared plus 11x plus 28. This is a 1x squared plus 9x plus 18. Now mind you, all trinomials can be done the same way, but these ones with ones are very, very simple. So that's what we're headed into. We're working with now three terms. So again, this says, you know, factor a polynomial where the coefficient from the x squared term is a 1, and we will get into factoring where the polynomial is something other than a 1, a 2, a 5, a 12, a 24, a 100. It can be anything. So before we go into this, let's just take any old binomial times another binomial and let's FOIL it. So I get x times x is x squared, and x times 4 is 4x, and 7 times x is 7x, and 7 times 4 is 28. And when I clean that up and combine these middle terms that are like terms, they add to be 11x. So I have x squared plus 11x plus 28. Well, you see this first problem we're going to do? Aha! I need to take this trinomial and factor it back into, I've got to factor it into x plus 7 times x plus 4, because I know that when I FOIL this, I get this. So let's see, what's the trick to this? Do you see the 7 and the 4? The 7 and the 4 multiplied to be the 28, the last term. Do you see the 7 and the 4? They became the middle terms, the 4x and the 7x. The 4 and the 7 add to be 11. So the constants at the back of the binomial add to be this middle term, and they multiply to be this last term, and then I can check them by FOILing to see how I did. So let's go to number 2 here. I'm looking for two numbers that add to be 9, and I want them to multiply to be 18. So again, I will often put, somehow I focus on the product first. What two numbers multiply to be 18? Now I'm going to play kind of ignorant or dumb on this. So, you know, 1 times 18 is 18, and 2 times 9 is 18, and 3 times 6 is 18. For that matter, a -1 times a -18 is 18, and a -2 times a -9, etc. But the two numbers that I pick, I want them to add to be the coefficient of the middle term, the 9. So I look right here and I see that 3 plus 6 is 9, so it's the number 3 and the number 6 that will go in the back of each of these binomials. The x times x is the x squared. I can put the 3 here and the 6 here, or I can put the 6 here and the 3 here. Either way, when I check this by taking x times x and getting x squared, and x times 3 and getting 3x, and 6 times x and getting that 6x, that's where the 3 and the 6 add to be the 9, and then 6 times 3 is 18. I can just go, oh yeah, check. I got the correct answer, either like this or like this. It doesn't matter which. I don't bother myself to memorize what goes on when I have a minus sign in front of the second term and a plus sign in front of the third term. I just write for myself a table. I'm looking for two numbers whose product is a positive 30. So their signs have to be the same. They have to either be both positive numbers or both negative numbers. And I want those two numbers to add to be a negative 11. And if you can see them right away, like by chance are you thinking of 6 and 5? Multiplies to be 30, but 6 and 5 doesn't add to be a negative 11, it adds to be a positive 11. So by chance do you think of a negative 6 and a negative 5 multiplies to be 30, and a negative 6 and a negative 5 adds to be the negative 11. So you'd come on over here and you'd put an a in the front of each of these because you need their product to be the a squared, and then a minus 6 in one of them, a minus 5 in the other, and FOIL it to check it. Now we'll be getting some problems where the numbers are difficult and you might not see it very readily. But go ahead and pause and try to do number 4. I'm going to go ahead and start though. I'm looking for two numbers whose product is the negative 21. I always think of those first for some reason. And I want those two numbers to add to be the positive 4 that's in front of the x. If two numbers' product is going to be a negative number, then one's got to be negative and one's got to be positive. So it could be like that. Those are my two options for 21. Or let's see, 3 and 7. So it could be a negative 3 and a positive 7, or it could be a positive 3 and a negative 7. All these combinations multiplied to be a negative 21. But it's this pairing right here, the negative 3 plus 7, that adds to be the 4. So when I factor this, I'm going to have an x in the front of each of these, but a minus 3 for this negative 3 and a plus 7. So be careful of your signs. They got to be properly placed. Now it's okay to write x plus 7 as your first binomial and x minus 3 as your second. But this cannot be a minus sign and this a plus sign, because if you use these two, 3 and a negative 7 add to be a negative 4, and we wanted it to add to be a positive 4. So look at number 5. Ha-ha. I have a feeling we have our answer right there, because the two numbers whose product is a negative 21 right here and adds to be a negative 4 would be a positive 3 and a negative 7. Unlike this one, which was a negative 3 and a positive 7, these had to be opposite. Again, don't forget, check. X times x is x squared. Then I have a minus 7x. Then I have a positive 3x. 3 times a minus 7 is a minus 21. This is what you got to really check. Does the middle term turn out to be this minus 4x? And sure enough, we're good. Let's see, how many more? We've got a few more, but what's going to happen here now is that you might get a greatest common factor. Oh, remember, broken record. Don't forget to take the greatest common factor out first. So it happens that this problem has x's in every one of these. So would you get the x out first? Don't do anything else. Don't be thinking about two numbers whose product is 15 and adds to be a negative 8. Don't go there. You need an x squared here, because x times x squared is x cubed. Then you'll need a minus 8x here, because x times a minus 8x is a minus 8x squared. And then you need a 15 here, because x times 15 is that 15x. So we took out the greatest common factor. Now you have a trinomial that's got an x squared in the front, a 1x squared in the front. So you know you're going to factor that into two binomials where you're going to have an x in the front of each of these. But now you need two numbers that their product is a positive 15. So their signs need to be the same. They need to add to be a negative 8. So if they've got to add to be a negative number, I'm only using negative values, because a negative times a negative is a positive. And of course, you probably already saw that a negative 3 times a negative 5 is a positive 15. And a negative 3 plus a negative 5 adds to be that negative 8. So we'll put in the minus 3 and the minus 5 in either of these. Don't forget to bring down the x, because that was the greatest common factor. And now we're all done. If I were to check this, I would FOIL this first and then multiply it all by x to see if I got what I started with. Let's look at a few more. So just because, I'm going to keep this right here. Just because we have p's and q's doesn't mean that it's not just a plain old trinomial that has a 1. in front of the squared term because it is. This is going to factor into a problem where I have to put a p in the front of each of these because I want their product to be p squared. So forget about all these p's and q's. I need two numbers whose product is the negative 24. Let's not think about the q's. And I want those two numbers to add to be the coefficient of the middle term, which is a negative 5. And so, you know, if you don't see that it's 8 and 3, because their signs are going to be opposites. So it's either going to be 1 and a negative 24 or a negative 1 and a positive 24. You know, if you don't see them real easily, just keep taking the number 24. Now divide it by 2. Oh, 2 goes in there 12 times. So I wonder, or don't even look and think about adding. Does 3 go into 24? Yeah, 3 goes into 24 8 times. And remember, the signs have to be opposite. So I'm trying to show you the pairings of numbers that multiply to be a negative 24. I got to pick the pairing right here that adds to be a negative 5. And it's a positive 3 and a negative 8. So I'm going to put a positive 3 here and a minus 8. But when I FOIL this, that last term has got to multiply to not just be a minus 24, it's got to be a minus 24 q squared. So I got to put a q here and a q here so that that will be the minus 24 q squared. I'm done. Let's check this out. So p times p is p squared. Here, this is where the PQ comes from. P times a minus 8Q is a minus 8PQ. 3 times QP is a positive 3, I'm going to write it as PQ. Positive 3 times a minus 8 is a minus 24. Q times Q is Q squared. And then these are like terms. They combine to be the middle term of a minus 5PQ. And I have successfully, because I have what I started with now, I have successfully found the factored form of this problem. Let's look at this one finally. So this one is called a perfect square trinomial, and it's kind of cool because I need two numbers that multiply to be 16. I'm guessing they're 4 times 4. I'm not going to think about 2 times 8 or 1 times 16. Because I want those two numbers to add to be 8, and I just happen to notice that 4 plus 4 adds to be 8. So when I factor this one, it's called a perfect square trinomial. Each of these binomials will be exactly alike. They're both going to have a positive 4 in the back, but they need to have a 4z in the back because 4z times 4z is the 16z squared. And then when you do this outside, you'll get a 4yz, and the inside, which is another 4yz, which totals to be the 8yz when you check it. And again, this is called a perfect square trinomial. Some people write this as y plus 4z, that quantity squared. When you close this video, would you work on the riddles that I gave you on page 90? And the riddle is called, when is a wrestler king of the ring? Wrestler, and I'm just going to say king here so you see it. All right, king of the ring. All right, very good.